These guys are hilarious. I love reading. Oh, I didn't see you come in. Hello there. I'm reading Freakonomics. This is my favorite book that I've ever read in my entire life. I highly suggest you check it out. You can come into my room in A149 and check it out from our math library. And this is a great connection to what you've already done in Algebra 2 with the supply and demand models that you did with your grasp. This is economics at its finest, supply and demand. Where they meet, that's the solution, that's the equilibrium price. So let's talk more about systems of equations, because that's really what you were talking about. So come on over and let's check out our whiteboards that I always have in my apartment. I love the whiteboard system. And so when we talk about a system, we're talking about something that has multiple components. Quit thinking about math right now. Think about a system in everyday life. You have the bus system, you have the metro system, you have the minor league baseball system. They all have many different components working together to reach a goal. So come down here, let's take down some vocabulary. System. Forget about math again, let's just talk about real world systems. All it means is having multiple components. Anything that has a lot of things going on at once is a system. We're having multiple components. And so when we're talking about a system of equations, we're talking about multiple equations with the same variables. So that could be x's, y's, r's, t's, z's, p's, m's, n's. Any couple equations with the same variables can work out to be a system. And so here's our vocabulary. We have that down. You have that in your lesson packet. Now let's talk about the 3 ways we can solve systems of equations. The first one is the easy way. Graphically. Anybody can draw things on a graph. And if you are one of those lucky few and smart ones about a TI-83, TI-83 Plus, or TI Inspire, you can graph it right on your calculator and see exactly where the 2 lines intersect. In this case, this is a very generic example. We have 2 lines that are plotted on the same graph, and their solution is right where they intersect. Simple as that. Just like your graphs, where supply equal demand, that was the equilibrium price, that's the solution. The solution is where they cross each other and they intersect each other. So right here. In this case, it would be 3, 2. The x value is 3, the y value is 2. Here's our solution. Whenever you solve a system of equations, you always write them in an XY format. Just like this. It's a solution, it's a point on a graph. Number 1 done. Next up, let's do some work. We got some algebra to do. It's substitution. When we talk about substitution, we talk about substituting one thing for another. Think about a substitute teacher. What happens? Your original teacher is not there because he's sick or she's sick, and then a substitute comes in and takes her place or his place. It's the same idea. We're taking one variable's quantity, its value, and placing it into another equation to get the other variable. I know that was a lot of words, but let's come over here and check it out. Here's how you do it. Substitution. We have 2 equations, y equals negative 2x plus 8, and y equals x minus 1. With substitution, all we're going to do is plug one of these variables, which is this one, y equals something, into the other equation, so we get one variable. So check this out. I know words don't always match up with what you're thinking, so let's do it. We're going to take x minus 1 and plug it into this y up here, because guess what? X minus 1 is the same thing as y, so let's do that. X minus 1 equals negative 2x plus 8. If I look at this equation now, I only see one variable. Ta-da! We can solve for x now. So what I'm going to do, I'm going to get this 2x on the other side by adding it. So now we're at 3x minus 1 equals 8. And now I'm going to get rid of this 1 by adding it. The opposite operation of subtraction is addition. So 3x equals 9. Divide by 3, because the opposite of multiplication is division. Divide by 3. So x equals 3. Alright, that's a good start, but we're not done yet. We need to get the y value, because the solution to a system of equations involves an x and a y. So let's take this x equals 3 and substitute it into, let's say, this x. We can substitute it in either x we want, but I think this one looks easier. So substitute this 3 in for that x. So let's rewrite that equation. Y equals 3 minus 1, that's some easy math. 3 minus 1 is 2. So now we have our x and our y. Let's write our solution, which is 3, 2. Ta-da! There's our solution. Not graphically, but by substitution. We took one equation, we took two equations, and we found out what x was and what y was, that both make those true. Alright? And our last one we're going to do is elimination. Elimination is my favorite because it's tricky. You got to be thinking. You got to be smart. It's like a puzzle. So come on, let's check it out. It's the same two equations, the same system. And our solution we know is going to end up being 3, 2. X is going to be 3, y is going to be 2. So here's how do you do elimination? Well, to eliminate something means to get rid of it. To eliminate a bad habit, you try to get rid of that bad habit. And so now we're going to try to eliminate one of the variables. And to do that, you can multiply one of the equations by anything you want, so that when you add the two equations together, you eliminate one of the variables. Again, a lot of words, let's actually see it in action. Well, I see this is negative 2x plus 8, and this is y equals x minus 1. I want to try to get rid of these x's for some reason. It's drawn to me. I want to get rid of the x's. So in order to add these and get 0, the opposite of negative 2 is a positive 2. So I need to multiply this entire equation by a positive 2 so that I can get rid of the x's. So 2, I'm going to rewrite the first equation because I changed nothing. And now I'm going to multiply this 2, distribute it throughout this second equation to make sure I get a positive 2x. So 2 times y is 2y. 2 times x is 2x. 2 times negative 1 is negative 2. And now I add the two equations. This is what it looks like. Y plus 2y is 3y. Negative 2x plus 2x. Uh-oh. X's are gone. 0 x's. Positive 8 minus 2 is a positive 6. And now I can rewrite it 3y equals 6. Get rid of the 3 by dividing it. Y is going to equal 2. And if you check out our other board, perfect. Y is 2, y is 2, we're good to go. But we're not quite done. We got to find x via elimination. All you got to do is plug this 2 back into any equation you want. Let's plug it back into that second one. 2 equals x minus 1. Add 1 to both sides. 3 equals x. Ta-da! It gets our answers. It's our solution that we saw in the substitution example and the graphic example. But let's write it appropriately. 3, 2. There's our solution. So to recap, solutions to a system of equations is where the two lines or the two equations intersect. That point where supply equals demand, just like your graphs. So you have a couple problems that you're going to work on. You're going to do great. We're going to rock it, and we're going to take the DC-CAS